Hello there, welcome to the AS Maths Applied June 2023 paper. Here we're looking at the final question for mechanics, which is question 4. A car of mass 1,200 is towing a trailer of mass 400 along a straight horizontal road using a tow rope, as shown in figure 2. The rope is horizontal and parallel to the direction of motion of the car. The resistance to motion of the car is modelled by a constant force of magnitude 2r. So that would be resistance of 2r. The resistance to motion of the trailer is modelled by a constant force of magnitude r. The rope is modelled as being light and inextensible, and the acceleration of the car is a meters per second. The driving force of the engine of the car is 7,400 newtons, and the tension in the rope is 2,400. So 2,400 here, and we've got a little 2,400 here. Using the model, find the acceleration of the car. Okay, let's reset the diagram. So let's add that back on. So 7,400. We had 2,400 here, 2,400 here. We had resistance to motion of r and resistance to motion of 2r. Okay, so we want to find the acceleration A of the whole car. So what we're going to do is I'm going to take all of the forces involved in that model and do an F equals ma on it. So I'll have the 7,000, so F equals ma. I'll have the 7,400 driving it forwards. These 2,400s just cancel each other out. So there'll be a point, the connection point to the trailer would be pulling 2,400 forwards, and the connection point to the car will be pulling it backwards by 2,400. So we don't need to write that in our equation, but we've got 3 lots of these resistances. So minus 3r equals mass times acceleration. Okay, so that is equation number 1. Let's maybe now just do an equation for this trailer here, and then we'll get 2 simultaneous equations and we can solve them. So another F equals mr, so ma. In this trailer, so let's go back to the previous one. M is the combined mass, so that's 1,600. Okay, back to the trailer. We have 2,400 driving it forward. We have one r value that's pulling it backwards, that's minus r, equals mass times acceleration. Right, okay, so what we're now going to do is rearrange these as simultaneous equations. So 7,400 equals 1,600a, add 3r, and 2,400 equals 400a, add r. These can now be typed into your calculator as simultaneous equations. And when we type these into the simultaneous equations in our calculators, we get A to be 0.5 meters per second squared. Lovely, there we are, that's the answer to part A. State how the value of A1, in the refined model, the rope is modelled as having a mass and acceleration of the car is found to be A1. State how the value of A1 compares to A. Well, if the rope has mass, then that will mean that the acceleration will be lower. So the value of A1 is less than A. Because it has mass, which will slow the car down. State one limitation of the model used for the resistance to motion of the car. State one limitation of the model used. Generally what happens is as the car gets faster and faster, the resistance force increases. So when the car is slow, there's a small resistance, and when the car is fast, there is a much greater resistance. So the limitation is that the reaction force is constant, whereas that is not the case in real life. So there we are, that's the answer to question 4, with a total of 7 marks there, and that has completed the mechanics section. So best of luck with all of your exams, and hopefully you found these videos helpful. Thanks for watching.